welcome to verifying solutions to a system and solving IVPs. So let's consider the system. Y prime is equal to the matrix 3, -1 as the first row, 6, -4 as the second row, times y plus the vector 2 and then 3. Verify that y equals -1/6 times the vector 5, 3, plus c1 times the vector 1, 1 times e to the 2t, plus c2 times the vector 1, 6 times e to the -3t is a solution for all c1 and c2. So we have y prime would be -1/6 times v3, vector v3 would just go to 0. So we'd have the 0 vector plus c1 times 1, 1 times 2e to the 2t plus c2 times the vector 1, 6 times -3e to the -3t. And then let's see what happens if we multiply by y and add the vector 2, 3. Sorry, if we multiply y by the original coefficient matrix and then add 2, 3. So using our equation, we have y prime should be equal to our matrix 3, -1, 6, -4 times y. So times -1/6 times the vector 5, 3 plus c1 times the vector 1, 1 times e to the 2t plus c2 times the vector 1, 6 times e to the -3t. And then all of that plus the vector 2, 3. So when we multiply this out, that first one we would be looking at -1/6 times, and we would have for our first row 5 times 3 is 15 plus 3 times -1, otherwise known as 12 for the first row. Then we have 6 times 5 is 30 plus -4 times 3, so 30 minus 12 is 18 for the second row. All that times -1/6. Then we have plus c1 times 3, -1, 6, -4 multiplied by 1, 1 would be 3 minus 1 or 2 for our first row, and 6 minus 4 or 2 for our second row, times e to the 2t. And then we have plus c2 times 3, -1, 6, -4 times the vector 1, 6. We would have 3 minus 6, otherwise known as -3 for our first row. And 6 minus -6 minus 24, otherwise known as -18 for our second row, e to the -3t, and then plus 2, 3, vector 2, 3. That -1/6 times 12, 18 cancels out precisely with our 2, 3. So we do get the 0 vector, or just nothing. That c1 times 2, 2 e to the 2t is just 1, 1 times 2 e to the 2t. That's c2 times -3, -18 times e to the -3t is simply c2 times 1, 6 times -3 e to the -3t. So since these match the original derivative, so this first one was just taking the derivative. So this one, the first one was via differentiation. And then the second version for y prime was using our equation. Since these two versions match, we have a solution. Next up, let's go ahead and solve the IVP. So this is the same equation. We just now have given ourselves the initial condition y0 or y of 0 is equal to 10, 3. So we have negative 1/6. So we know y should be equal to negative 1/6 times the vector 5, 3 plus c1 times the vector 1, 1 times e to the 2t plus c2 times the vector 1, 6 times e to the negative 3t. And we have y of 0. Plugging that in, we would just have negative 1/6 times the vector 5, 3 plus c1 times the vector 1, 1 plus c2 times the vector 1, 6. This should be equal to the vector 10, 3. So we have c1 times 1, 1 plus c2 times 1, 6 is equal to 10, 3 plus 1, 6 times 5, 3. I'm going to go ahead and just multiply everything through by 6. So I don't have to work with fractions. I need to update my screen quickly first. Multiplying everything through by 6, this is equivalent to c1 times 6, 6 plus c2 times 6, 36 is equal to, we would have 60 plus 5 is 65 for our first row on the right. And then 18 plus 3 is 21 for our second row on the right. So we're essentially solving the system 6, 6, 6, 36 times C1, C2 is equal to 65, 21. You can solve this using whatever technique you want. This becomes 6, 6, 65 if we do the augmented matrix, and then we would have 0. Let's do second equation minus the first, so 0, 30, and then 21 minus 65 should be a negative 44. So we get C2 would be negative 44 30ths or negative 22 15ths. C1, we would have 6C1. I need to update. Sorry, so our first row, take this a slightly different route, would be rewritten as just 1, 1 and 65, 6. So we have C1 plus C2 is 65 sixths. So C1 would be 22 15ths plus 65 sixths, otherwise known as 44 30ths plus 325 30ths. or 369/30 dividing by 3, we're left with 123/10. So we have that our y is equal to -1/6 times the vector 5, 3 plus 123/10 times the vector 1, 1 times e to the 2t minus 22/15 times the vector 1, 6 times e to the -3t. I apologize that last bit's not updating. There it is. So if once we have our sort of general solution, solving the IVP is not really any more complicated than solving a general silane IVPs as we've done just for differential equations and not systems. So this is how you can go about verifying something as a solution, as well as solving the IVP once you have a general solution.